Hey guys, tonight we dive into a whirlwind of brain-bending paradoxes that'll twist your mind like a cosmic pretzel. Picture yourself sprawled on a couch, the room bathed in the soft glow of a lava lamp, as you wrestle with ideas that make reality feel like a glitchy simulation. These paradoxes, spanning time, space, and logic, might just keep you awake or lull you into a dreamy haze. Fair warning, your brain probably won't survive this unscathed. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Drop a comment with your city and local time. I'm curious where you're drifting off tonight. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You start with the enigma of time's relentless march. Why does it only flow one way? You wake up, sip coffee, and stumble through your day, never backward. This is the arrow of time paradox, and it's a beast. The universe, born in a hot, chaotic Big Bang, keeps spreading out, cooling down like spilled milk you can't unspill. Entropy, that measure of disorder, always climbs. A mainstream fact: the second law of thermodynamics says entropy in a closed system never decreases, locking time's direction. But here Dolores, a quirky tidbit. Ancient Egyptians used crocodile dung as sunscreen, messy but effective, much like time's messy one-way street. Historians still argue whether time's arrow is truly absolute or if quantum mechanics might allow rare reversals. Imagine you're sipping tea watching a sugar cube dissolve. It doesn't undissolve. That's entropy at work. Things fall apart, never together. Yet you wonder, could time loop back? Some physicists toy with closed time-like curves, where you could revisit yesterday. Sounds cool, but it's a mathematical fever dream, not a DeLorean. You chuckle, picturing yourself stuck in a cosmic Groundhog Day, reliving bad hair days forever. The paradox bites because, despite time's forward march, you feel it differently. Hours drag during meetings, but vacations vanish. Relativity adds a twist. Time slows near black holes. So, theoretically, you could age slower than your twin on Earth, but good luck surviving the trip. Now let's poke deeper. If the universe rewound, would you notice? A reversed Big Crunch would look like another Big Bang. Your brain spins. You're lying in bed, fan humming, and realize time's arrow pins you to now. No rewinds. No pauses. Philosophers like Augustine muse time exists only in your mind. A quirky thought, but unhelpful when you're late for work. Modern cosmology suggests time began 13.8 billion years ago, yet before the Big Bang is a nonsense question, like asking what's north of the North Pole. You smirk, imagining a cosmic customer service desk refusing your return time request. This paradox isn't just physics, it's personal. You can't undo that cringeworthy text you sent last week. Time's arrow stabs forward and you're along for the ride. As you drift, the room's shadows stretch and you wonder, is time's direction just the universe's way of keeping you humble? You're still reeling from time's one-way street, that cosmic conveyor belt you can't hop off. Now, you stumble into a paradox that makes walking itself feel like a scam. Welcome to Zeno's motion mirage, where a Greek philosopher with too much time on his hands, ironic, right, decides to mess with your head. Picture yourself strolling across your room, aiming for that cozy blanket. Seems simple. But Zeno, chilling in ancient Elia around 450 BCE, says you'll never get there. A mainstream fact: Zeno of Elia's paradoxes, recorded by Aristotle, challenged ideas of motion and infinity, shaping mathematical thought. Historians still argue whether Zeno meant to deny motion outright or just troll his rivals. And here's a quirky tidbit. Zeno's teacher, Parmenides, once argued reality is one unchanging blob. Imagine pitching that at a TED Talk. Zeno's trick is the dichotomy paradox. To reach that blanket, you first cover half the distance. Easy. But then you must cover half of what's left. Then half of that. And so on, forever. Each step shrinks, but there's always another half to go. You're stuck in an infinite series of tasks, like a cosmic to-do list from hell. You chuckle, picturing yourself trapped mid-stride, blanket taunting you like a mirage. Mathematically, these halves, 1/2, 1/4, 1/8, add up to the full distance, but Zeno smirks. How do you finish infinite steps in finite time? You pause, fan still humming from last section's setup, and rethink walking. Your brain screams, I move every day. Yet Zeno's logic feels airtight. You try sprinting to outsmart him, but nope, same problem. Half, then half, then half again. It's like scrolling X endlessly, there's always more. Modern math saves you, sort of. Calculus, thanks to Newton and Leibniz, sums infinite series. Those halves converge to one, so you do reach the blanket. But Zeno's ghost cackles. Convergence is a description, not an explanation. How do you actually complete infinite divisions? You sink deeper, imagining an arrow flying to a target, another of Zeno's traps. To hit the bullseye, it covers half the distance, then half again, never arriving. Yet arrows hit targets. You've seen it. So what gives? Some philosophers say space and time aren't infinitely divisible. There's a smallest unit, like reality's pixel. Quantum mechanics hints at this with Planck length, about 1.6 times 10 superscript 3 meters. You smirk, wondering if Zeno would have loved string theory or just argued it still turtles all the way down. Now picture running a race. Zeno's third paradox, Achilles and the tortoise, sneaks in. Achilles, the Usain Bolt of myth, chases a tortoise with a head start. By the time Achilles reaches where the tortoise was, it's crawled forward. Repeat forever. Achilles never catches up despite being faster. You laugh, imagining a tortoise trash-talking Achilles on X. Catch me if you can, bro. Yet, calculus again resolves it. The infinite sum of shrinking gaps has a finite limit. Still, your gut twists. Zeno's not wrong, he's just annoying. This paradox lingers like a bad dream. You're lying there, room dim, wondering if motion's an illusion. Philosophers like Bertrand Russell called Zeno a genius for exposing infinity's quirks. Others, like Diogenes, reportedly just walked away to disprove him. Classic flex. You relate to Diogenes, you want to grab that blanket and yell, "Take that, Zeno!" But the paradox clings. If space is divisible forever, how do you cross it? If it's not, what's the smallest chunk? You drift, fans hum fading, as Zeno's mirage makes every step feel like a leap of faith. You're still shaking off Zeno's trap, that infuriating moment where you questioned if you could even move. The blanket's within reach now, but your mind's already halfway across the universe, tangled in a new paradox that makes Zeno's wordplay feel like a warm-up. You're stepping into the grandfather paradox, the time travel headache that asks, what happens if you mess with your own past? Picture yourself in a creaky time machine, dials glowing as you zip back to 1950 to meet your grandpa. A mainstream fact: H.G. Wells' 1895 novel The Time Machine popularized time travel in fiction, sparking debates about its logic. Historians still argue whether time travel paradoxes expose flaws in causality or just our imaginations running wild. For a quirky tidbit, in 2009 Stephen Hawking threw a party for time travelers. No one showed up, but he sent invites after the event, just in case. Here's the setup. You find young grandpa at a soda fountain, all slick hair and charm. But, for reasons we'll keep PG-13, maybe he stole your favorite comic, you decide to stop him from meeting grandma. No marriage, no parents, no you. So, you slip a fake bus ticket into his pocket, sending him across the country. Success. But wait. If you were never born, how are you here, sipping root beer and sabotaging grandpa's love life? Your head throbs like you've binged too much sci-fi on X. You chuckle, imagining a cosmic HR department firing you for breaking reality. This paradox is a causal loop's worst nightmare. Causality, the rule that effects follow causes, is the universe's glue. You break it and time's arrow, that one-way street from section 1, snaps like a cheap guitar string. One fix is this self-consistency principle, proposed by physicist Igor Novikov. It says the universe conspires to stop you. Maybe the bus crashes, grandpa hitchhikes back and meets grandma anyway. You groan, picturing the universe as a meddling sitcom writer, always patching plot holes. Another theory's wilder: parallel universes. You kill grandpa and poof, you're in a new timeline where you were never born, but the original timeline chugs along fine. This many-worlds idea, rooted in quantum mechanics, suggests every choice splits reality. You smirk, wondering if there's a timeline where you're a pro skateboarder instead of pondering paradoxes at 8:10 p.m. Pacific Daylight Time. But parallel worlds don't solve everything. How do you exist to travel back if your birth's erased in this timeline? The fans hum from your room, still spinning from section 1, feels like the only constant. Now let's twist it. Suppose you don't kill grandpa but give him a winning lottery ticket. He gets rich, your family's loaded, and you grow up with a pet robot. Does that change who you are now mid-time travel? Some say time's immutable, you're locked in a loop, doomed to repeat the ticket trick forever. Others argue for a block universe, where past, present, and future coexist, and your meddling's already baked in. You laugh, imagining a cosmic baker kneading your bad decisions into time's dough. This paradox stings because it's personal. You can't undo that awkward high school dance, but time travel teases the fantasy. Yet, every fix, consistency, multiverses, block time, feels like cheating. You're lying there, shadows dancing on your ceiling, wondering if free will's an illusion. If you went back, would you even choose differently, or is the script already written? The grandfather paradox doesn't just break time. It breaks you, leaving you to drift, fan humming as you question whether you're the cause or just the effect. You're still dizzy from dodging the grandfather paradox, that gut punch where you nearly erased yourself over a soda fountain scheme. The fan's hum, steady since you dimmed the lights, anchors you as you slide into a new mind bender, Schrödinger's cat conundrum. This one's a quantum quirk that makes time travel seem like a breezy Sunday drive. Picture yourself in a lab, not some retro 1950s diner, but a sterile room with humming machines and a sealed steel box. Inside, a cat, a vial of poison, and a radioactive atom. A mainstream fact. Erwin Schrödinger proposed this thought experiment in 1935 to highlight quantum mechanics' weirdness, specifically the Copenhagen interpretation. Historians still argue whether Schrödinger meant to mock the theory or clarify it. For a quirky tidbit, Schrödinger once quipped he wished he'd never met that cat. Guess even he got tired of the paradox's fame. Here's the deal. The atom might decay, triggering the poison, killing the cat. Or it might not. Quantum mechanics says until you observe it, the atom is in a superposition, both decayed and not. So the cat's both dead and alive until you open the box. You're standing there, lab coat optional, wondering if you're about to meet a purring pal or a feline tragedy. You chuckle, imagining the cat posting on X. Schrödinger's box is not OSHA compliant. But seriously, how's the cat both? Your brain's doing somersaults. This paradox isn't about time's arrow or infinite halves. It's about reality itself. Quantum superposition means particles exist in multiple states until measured. You think of the sugar cube dissolving back in section 1. It's either dissolved or not both. But in quantum land it could be. The Copenhagen interpretation, championed by Niels Bohr, says observation collapses the superposition into one outcome. So you open the box and the cat's either meowing or not. But until then it's a zombie cat defying logic. You smirk, picturing a cosmic coin toss where the coin's heads and tails mid-air. Now let's mess with it. What if you never open the box? Does the cat stay in limbo forever? Some physicists like Hugh Everett push the many worlds idea from section 3. In one universe you open the box and cry over a dead cat. In another you're scratching its ears. You're splitting realities just by peeking. It's like choosing between pizza or tacos and getting both in parallel worlds. But the fan's hum reminds you, you're in this reality where choices feel singular and cats don't play quantum roulette. Here's where it gets personal. You're lying in bed, not a lab, but the paradox claws at you. Is your life in superposition? Are you both succeeding and failing until someone observes you? Social media feels like that. Your ex post is a hit and a flop until likes roll in. Philosophers love this conundrum because it questions what's real. If the cat state depends on you, are you shaping reality? You laugh, imagining a world where your snooze button habit collapses the universe's wave function. The quirky part? This thought experiment's so famous, it's on t-shirts, yet most physicists agree it's impractical. Radioactive decay's too messy for a clean setup. Still, experiments with particles like electrons and double-slit tests confirm superposition's real. You're drifting, the room's shadows softening, wondering if you're just a wave function waiting to collapse. Schrödinger's cat doesn't just mess with physics. It messes with you, leaving you to ponder, fan humming, whether reality's only real when you look at it. You're still reeling from Schrödinger's cat, that quantum furball haunting your dreams as both alive and dead. The fan's gentle hum, a constant since you dimmed the lights, pulls you back from the lab and into a new paradox that makes zombie cats seem tame. Welcome to the bootstrap paradox, where you're not just questioning reality but chasing objects and ideas with no beginning. Picture yourself rummaging through a dusty attic, not a sterile lab, and finding a worn notebook filled with your handwriting, except you've never seen it before. A mainstream fact. The term bootstrap paradox comes from Robert A. Heinlein's 1941 story By His Bootstraps, which toyed with time travel loops. Historians still argue whether such paradoxes prove time travel's impossible or just expose gaps in our causal logic. For a quirky tidbit, in 2014, a Russian man claimed he found a 100-year-old photo of himself in a time travel experiment. Spoiler, it was debunked, but the internet ate it up. Here's the setup. You open the notebook and it's a guide to building a time machine, step by step, in your scrawled penmanship. You follow it, build the machine, and zip back to 1980 to drop the notebook in that same attic. Fast forward, you find it today and repeat the cycle. So, where did the notebook come from? It has no origin. It's a causal orphan bootstrapped into existence by your time-hopping antics. You chuckle, imagining the notebook smirking at you like a smug artifact saying, "Figure that out." It's like the crocodile dung sunscreen from section 1, effective but inexplicably there. This paradox is a dagger to causality, that glue from the grandfather paradox holding reality together. If the notebook's information exists without a source, what's stopping entire histories from popping up uncaused? You picture a world where hit songs or inventions, like say the wheel, appear because a time traveler borrowed them from the future. Some physicists dodge this with Novikov's self-consistency principle, met in section 3, saying time loops are stable, no new info sneaks in. The notebook's always been part of the timeline like a cosmic rerun. You groan, picturing the universe as a lazy editor recycling plotlines. But let's twist it. Suppose you don't just find a notebook but a song, your favorite banger, one you write after hearing it in the future. You travel back, perform it, and it becomes a classic. Who composed it? Nobody. It's a melody without a muse, looping forever. You smirk, imagining a time traveler accidentally inventing TikTok dances centuries early. The many-worlds theory from sections 3 and 4 could help. Maybe each loop spawns a new universe, but that feels like piling paradoxes on paradoxes, like stacking turtles from Zeno's day. This hits home as you lie there, shadows shifting in your room. Ever feel like your ideas aren't yours? Maybe that brilliant X-post you crafted was inspired by a future you. The bootstrap paradox suggests information can float free, unmoored from origins like a ghost ship. Philosophers wrestle with this, asking if free will survives in a world where your actions might be echoes of a future self. You laugh, picturing a cosmic plagiarism checker flagging your life as source unknown. The paradox lingers like a catchy tune you can't unhear. If time travel's real, could you bootstrap your way to genius? Or are you trapped in a loop, passing notes to yourself across decades? The fan hums, the attic's dust settles in your mind, and you drift, wondering if every great idea is just a time traveler's hand-me-down. You're still untangling the bootstrap paradox, that notebook with no author taunting you from a dusty attic. The fan's hum, your trusty companion since the lights dimmed, keeps you grounded as you pivot to a paradox that swaps time loops for cosmic silence. Welcome to Fermi's alien silence, where you're not chasing your own handwriting but wondering why the universe's inbox is empty. Picture yourself on a hilltop, not an attic, staring at a sky ablaze with stars, telescope in hand, waiting for ET to ping you. A mainstream fact: Enrico Fermi posed this question in 1950 during a casual lunch at Los Alamos, sparking the Fermi paradox. Historians still argue whether Fermi was skeptical of alien life or just puzzled by the lack of evidence. For a quirky tidbit, in 1977 the WOW! Signal, a 72-second radio burst, teased astronomers with possible alien origins, but it's never repeated, leaving us ghosted. Here's the deal. The universe is vast, 100 billion galaxies, each stuffed with stars and planets. Earth's a speck, yet life bloomed here. So where are the aliens? You scan the stars, expecting radio signals, spaceships, or even a cosmic X-post saying, "Humans, you good?" But it's crickets. The Drake equation, cooked up by Frank Drake in 1961, estimates thousands of communicative civilizations should exist in our galaxy alone. Yet no one's calling. You chuckle, imagining aliens scrolling past Earth's vibe check like, nah, too much drama. This paradox stings because it's not just math, it's existential. Are we alone? One answer's the great filter. Maybe life's common, but intelligent life hits a wall, like self-destruction or tech limits. You shudder, thinking of nuclear war or AI gone rogue, wondering if we're past the filter or doomed to flunk it. Another theory's the zoo hypothesis. Aliens are watching, but we're like ants in a terrarium, too primitive for contact. You smirk, picturing a galactic reality show where Earth's the chaotic season finale. Let's twist it. Maybe aliens use tech we can't detect, like neutrino beams instead of radio waves. Or they're post-biological, living in digital realms, ignoring our analog shouts. You recall the sugar cube from section 1, dissolving predictably, unlike alien motives. The rare Earth hypothesis suggests Earth's conditions, stable star, just right orbit, are cosmic flukes. But with exoplanets popping up like cosmic popcorn, that feels shaky. You lie there, fan humming, wondering if aliens are just introverts ghosting us on purpose. This hits close. You felt alone in a crowded room, right? Fermi's paradox scales that to the cosmos. If intelligent life's out there, why the silent treatment? Some say we're early to the galactic party, stars are young and we're the first to RSVP. Others argue advanced civs go quiet, hiding from predators. You laugh, imagining a galactic group chat where Earth's the only one typing. Said he's been listening for decades but no dice. The WOW! Signals a tease like that notebook from section 5. Intriguing but no source. The paradox lingers as you gaze at your ceiling, stars invisible but felt. Are we shouting into a void, or is someone listening too shy to reply? The fan's hum blends with the night, and you drift, pondering if the universe's silence is a snub or just a really long voicemail. You're still untangling the bootstrap paradox, that notebook with no author taunting you from a dusty attic. The fan's hum, your trusty companion since the lights dimmed, keeps you grounded as you pivot to a paradox that swaps time loops for cosmic silence. Welcome to Fermi's alien silence, where you're not chasing your own handwriting but wondering why the universe's inbox is empty. Picture yourself on a hilltop, not an attic, staring at a sky ablaze with stars, telescope in hand, waiting for ET to ping you. A mainstream fact. Enrico Fermi posed this question in 1950 during a casual lunch at Los Alamos, sparking the Fermi paradox. Historians still argue whether Fermi was skeptical of alien life or just puzzled by the lack of evidence. For a quirky tidbit, in 1977 the WOW! Signal, a 72-second radio burst, teased astronomers with possible alien origins, but it's never repeated, leaving us ghosted. Here's the deal. The universe is vast, 100 billion galaxies, each stuffed with stars and planets. Earth's a speck, yet life bloomed here. So where are the aliens? You scan the stars, expecting radio signals, spaceships, or even a cosmic X post saying, "Humans, you good?" But it's crickets. The Drake equation, cooked up by Frank Drake in 1961, estimates thousands of communicative civilizations should exist in our galaxy alone. Yet no one's calling. You chuckle, imagining aliens scrolling past Earth's vibe check like, nah, too much drama. This paradox stings because it's not just math, it's existential. Are we alone? One answer's the great filter. Maybe life's common, but intelligent life hits a wall, like self-destruction or tech limits. You shudder, thinking of nuclear war or AI gone rogue, wondering if we're past the filter or doomed to flunk it. Another theory's the zoo hypothesis. Aliens are watching, but we're like ants in a terrarium, too primitive for contact. You smirk, picturing a galactic reality show where Earth's the chaotic season finale. Let's twist it. Maybe aliens use tech we can't detect, like neutrino beams instead of radio waves. Or they're post-biological, living in digital realms, ignoring our analog shouts. You recall the sugar cube from section 1, dissolving predictably, unlike alien motives. The rare Earth hypothesis suggests Earth's conditions, stable star, just right orbit, are cosmic flukes. But with exoplanets popping up like cosmic popcorn, that feels shaky. You lie there, fan humming, wondering if aliens are just introverts ghosting us on purpose. This hits close. You felt alone in a crowded room, right? Fermi's paradox scales that to the cosmos. If intelligent life's out there, why the silent treatment? Some say we're early to the galactic party, stars are young and we're the first to RSVP. Others argue advanced civs go quiet, hiding from predators. You laugh, imagining a galactic group chat where Earth's the only one typing. Said he's been listening for decades but no dice. The WOW! Signals a tease like that notebook from section 5. Intriguing but no source. The paradox lingers as you gaze at your ceiling, stars invisible but felt. Are we shouting into a void, or is someone listening too shy to reply? The fan's hum blends with the night, and you drift, pondering if the universe's silence is a snub or just a really long voicemail. You're still reeling from Russell's set riddle, that logical labyrinth where sets argued with themselves like a bad X thread. The fan's hum, your steady companion since the lights dimmed, pulls you from the chalk-dusted library into a new paradox that swaps self-referential traps for an infinite hotel. Welcome to Hilbert's Infinite Hotel, where you're checking into a place that defies common sense. Picture yourself at a grand hotel, not a dusty library with neon signs flashing, no vacancy, and an infinite number of rooms stretching down an endless hallway. A mainstream fact. David Hilbert proposed this thought experiment in 1924 to illustrate the bizarre nature of infinite sets in mathematics. Historians still argue whether Hilbert's hotel clarifies infinity or just boggles the mind for fun. For a quirky tidbit, Hilbert once joked that infinity is where there's always room for one more. A line you'd hear from a cosmic concierge. Here's the setup. You stroll up to the front desk, luggage in tow, and the clerk says every room's taken. Infinitely many guests, one per room. Bummer. But then the clerk grins and says, no problem, we'll make space. They shift every guest down one room, room 1 to 2, 2 to 3, and so on. Now room 1's free for you. Your jaw drops. How's that possible in a full hotel? You chuckle, imagining an ex post from a disgruntled guest. Move to room 100001. Send help. It's like Zeno's infinite halves from section 2, but now it's rooms, not distances, playing tricks. This paradox is about infinity's weirdness. Finite hotels can't pull this stunt. If 100 rooms are full, you're sleeping in the car. But infinity's different. The hotel can absorb not just you but an infinite busload of new guests. Pair each new guest with an even-numbered room, 2, 4, 6. Shift old guests to odd numbers, 1, 3, 5, and everyone's housed. You're lying there, fan humming, picturing an infinite conga line of guests shuffling forever. George Cantor's set theory, which Russell poked holes in during section 7, backs this up. Infinite sets can be manipulated in ways finite ones can't. Let's twist it. Suppose an infinite number of infinite buses arrive, each with infinite passengers. The clerk doesn't blink. They use a clever pairing trick, like mapping rooms to coordinates on a grid, to fit everyone. Your brain's doing cartwheels. This isn't just math, it's a reality check. Infinity doesn't behave like your bank account. You smirk, imagining a cosmic hotel chain advertising, infinite Wi-Fi, infinite problems. Yet, some infinities are bigger than others. Cantor proved the set of real numbers dwarfs the set of integers, a twist that makes Hilbert's hotel feel like a cozy B&B. This hits home as you stare at your ceiling, shadows swaying. Ever feel like your to-do list is infinite? Hilbert's hotel says you can always squeeze in one more task, but it's exhausting. Philosophers wrestle with whether infinity's a real thing or just a mental toy. You recall the aliens from section 6. Maybe they're hiding in an infinite hotel, ignoring our calls. You laugh, picturing a galactic desk clerk saying, "Sorry Earth, we're booked." The paradox lingers like a check-in line that never ends, leaving you to drift, fans hum fading, wondering if infinity's a gift or a glitch in the universe's code. You're still checking out of Hilbert's infinite hotel, that surreal lobby where infinity made room for everyone, no questions asked. The fans hum, your bedtime tether since the lights dimmed, guides you from neon-lit hallways into a paradox that swaps endless rooms for a pile of sand. Welcome to Sorite's vague heap, where you're not juggling infinite guests but questioning when a handful of grains becomes a heap. Picture yourself on a beach, not a hotel, toes in the sand, scooping grains into a pile under a fading sunset. A mainstream fact. The Sorite's paradox, attributed to Eubulides of Miletus around the 4th century BCE, challenges the logic of vague concepts. Historians still argue whether Eubulides meant to expose flaws in language or just stump his students. For a quirky tidbit, ancient Greeks loved debating paradoxes over wine. Imagine Eubulides trolling his pals with sand piles at a beach party. Here's the setup. You drop one grain of sand. Is it a heap? Nah, it's just a grain. Add another. Still not a heap. Keep going, 3 for 10 grains. At what point does your pile graduate to heap status? You can't pinpoint it. If 1,000 grains is a heap, is 999 not? Removing one grain shouldn't undo a heap, right? Your brain's doing flips like a seagull diving for fries. You chuckle, imagining an ex-post, just made a heap. Or did I? #philosophybeach. It's like Zeno's halves from section 2, slicing precision, but now it's vagueness slicing your logic. This paradox is about blurry boundaries. Words like heap, tall, or bald are vague, unlike math's clean edges. You recall Russell's set riddle from section 7. Sets were crisp until they weren't. Here, logic crumbles because no single grain flips the switch. One fix is denying vagueness exists. Maybe there's a secret cutoff, like exactly 1,237 grains, known only to the universe. You smirk, picturing a cosmic rulebook listing official heap thresholds. Another approach, supervaluationism, says vague terms have multiple precise meanings and truth depends on context. But that feels like dodging the problem, like saying Schrodinger's cat from section 4 is kinda alive. Let's twist it. Instead of sand, imagine losing hair. One strand falls out, not bald. Another? Still not bald. When are you bald? You laugh, picturing a mirror moment where you suddenly yell, "I'm officially bald." Life's full of these vague shifts. When's a kid an adult? When's a hobby an obsession? The paradox stings because it's practical. You're lying there, fan humming, wondering if your small coffee addiction's a heap of trouble. Philosophers like Timothy Williamson argue vagueness is epistemic, we're just ignorant of the cutoff. Others say it's linguistic, a flaw in how we talk. This hits close. Ever hesitate to call something done or good enough? Sorite's messes with decisions like whether one more X scroll makes you addicted. The paradox suggests precision's a myth in a fuzzy world. You recall the aliens from section 6. Maybe their silence is a vague not yet rather than a hard no. As the beach fades, sand slipping through your fingers, you drift, fans hum softening, wondering if life's heaps, love, success, even sleep, are just piles we name without knowing why. You're still brushing sand off your hands from Sorite's vague heap, that beachside puzzle where piles defy definition. The fans hum, your cozy constant since the lights dimmed, pulls you from the sunset shore into a paradox that swaps fuzzy boundaries for a sentence that eats itself. Welcome to the liar's truthful deception, where you're not counting grains but wrestling with words that twist like a snake biting its tail. Picture yourself in a quiet cafe, not a beach, scribbling on a napkin. This sentence is false. A mainstream fact, the liar paradox, traced to ancient Greece around the 4th century BCE, is often linked to Epimenides, a Cretan who said, "All Cretans are liars." Historians still argue whether the paradox reveals flaws in language or deeper truths about logic. For a quirky tidbit, in 1931, philosopher Alfred Tarski used the liar to argue truth can't be defined within a language. Imagine pitching that over coffee. Here's the setup. You stare at your napkin. If this sentence is false, is true, it's false as it claims. But if it's false, it's true because it accurately says so. Your brain's doing loops like a barista steaming milk wrong. You chuckle, imagining the napkin tweeting on X, "I'm false. Or am I? #LiarLife." It's like Russell's set riddle from Section 7, where self-reference broke logic, but now it's a single sentence playing saboteur. This paradox is a logic bomb. Truth and falsity are supposed to be clear, like the sugar cube dissolving in Section 1. Either it's gone or it's not. But the liar laughs at that. One fix is banning self-reference, like telling the sentence, "Stop talking about yourself." Formal logic systems, like those post-Russell, avoid these loops by layering languages. Truth lives upstairs, not in the sentence's basement. But you smirk, picturing a cosmic editor redlining your napkin. Too meta, rewrite. Another approach, par-consistent logic, says some statements can be both true and false, which feels like letting the paradox win. Let's twist it. Suppose you meet a robot programmed to say, "I'm lying." Is it? If it's lying, it's telling the truth, but then it's not lying. You laugh, imagining the robot short-circuiting, smoke curling like your cafe's espresso steam. This isn't just academic, computers hate self-reference. Ever get a does not compute vibe from a crashed app? The liar's to blame. Philosophers like Saul Kripke suggest truth gaps. Some sentences are neither true nor false, floating in limbo like Schrodinger's cat from Section 4. This hits home as you lie there, fan humming, shadows stretching across your room. Ever said, "I'm fine," when you weren't? Your words felt like a mini liar dodging truth. The paradox questions trust. In language, in yourself. You recall the notebook from Section 5, looping without origin. This sentence loops without landing. Some say context saves us. Truth depends on who's reading the napkin. But in bed, 8:26 p.m. Pacific Daylight Time, context just you and the dark. You're drifting, cafe fading, wondering if truth's a game where the rules keep lying to you. You're still sipping coffee in that cafe, the liar paradox's napkin crumpled in your hand, its self-eating words leaving a bitter aftertaste. The fans hum, your steady guide since the lights dimmed, pulls you from the espresso haze into a paradox that swaps linguistic traps for numbers too slippery to name. Welcome to Barry's unspeakable number, where you're not wrestling with sentences but chasing digits that dodge definition. Picture yourself in a mathematician's office, not a cafe, surrounded by whiteboards scrawled with equations, a single number haunting the room like a ghost. A mainstream fact. George Barry, a librarian, inspired this paradox in 1904, which Bertrand Russell formalized to expose limits in describing numbers with language. Historians still argue whether Barry's paradox undermines formal mathematics or just highlights language's clumsiness. For a quirky tidbit, Russell once received a letter from a reader claiming to have named the unnameable number. Spoiler, it was just a prank. Here's the setup. You're tasked with naming all numbers using English descriptions under 100 words. Easy ones first. 1, the square of 2, 1,000,000 plus 1. But now consider the smallest number that can't be described in under 100 words. Call it B. By defining it as the smallest number not describable in under 100 words, you've just described it in fewer than 100 words. Boom, contradiction. Your brain's buckling like a whiteboard marker running dry. You chuckle, imagining B tweeting on X, "I'm too big to name, but oops." It's like the liar paradox from Section 10, but now numbers, not sentences, are the tricksters. This paradox is a jab at description itself. Numbers should be tame, count the grains in Section 9's heap and you're fine. But Barry's number slips away, like the notebook from Section 5 with no origin. One fix is separating levels of language as Tarski did for the lyre. Mathematical descriptions live in a meta-realm, so B's definition doesn't count as a valid name. You smirk, picturing a cosmic librarian shushing you, no self-naming numbers allowed. Another approach from Gödel's work suggests some truths, like B's identity, can't be pinned down in any system. Let's twist it. Imagine a computer tasked with listing all describable numbers. It hums along, but when it hits B, it crashes, unable to name what it just defined. You laugh, picturing the computer posting a 404 error, number not found. This isn't just math, it's tech's Achilles heel. Ever hit a software glitch that feels like Russell's set riddle from Section 7? Barry's paradox haunts those bugs. Philosophers like Wittgenstein argued language's limits shape our reality, and B proves it. Some things exist but defy naming. This hits home as you lie there, fan humming, shadows pooling at 8:30 p.m. Pacific Daylight Time. Ever felt a thought you couldn't express? Barry's number is that thought, but for math. You recall Schrödinger's cat from Section 4. Alive, dead, unnameable until observed. Maybe life's big questions, love, purpose, are like B, real but unspeakable. The paradox lingers like an equation with no solution, leaving you drifting, white bars fading, wondering if some truths or numbers we'll never write down. You're still wiping whiteboard dust from your hands, Barry's unspeakable number leaving you grasping for digits that slip through language like sand from Section 9's vague heap. The fan's hum, your bedtime beacon since the lights dimmed, steers you from the mathematician's office into a paradox that swaps unnameable numbers for a cosmic race against time. Welcome to the twin paradox twist, where you're not chasing numbers but aging differently aboard a speeding spaceship. Picture yourself in a sleek spacecraft, not a cluttered office, stars streaking past as Earth shrinks in the rear view. A mainstream fact: Albert Einstein's 1905 theory of special relativity predicts time dilation, which the twin paradox illustrates. Historians still argue whether the paradox is a true contradiction or just a quirky thought experiment. For a quirky tidbit, in 1971 physicists flew atomic clocks on jets to test time dilation. Spoiler, the clocks slowed, proving Einstein right. Here's the setup. You and your twin, let's call her Tara, start on Earth, both 30 years old. You blast off at near light speed, cruising for what feels like 5 years aboard your ship. Thanks to relativity, time crawls for you compared to Earth. When you return, Tara's 40, gray creeping into her hair, while you're barely 35, still rocking that youthful glow. Time dilation. Moving fast stretches time like cosmic taffy. You chuckle, imagining Tara's ex-post, "My twin's younger now." Hashtag relativity sucks. It's not like the grandfather paradox from Section 3, you're not breaking causality, just bending time's arrow from Section 1. This paradox feels like a cheat. Why do you age less? Special relativity says time's relative to your speed. Your ship's clock ticks slower compared to Tara's earthbound one. But here's the twist. From your perspective, Tara's moving away, so shouldn't she age slower? The symmetry breaks because you accelerate. Turning around to return home involves forces that anchor Tara's frame as stationary. You're lying there, fan humming at 8:31 p.m. Pacific Daylight Time, picturing a cosmic referee declaring Earth the winner. Experiments like those jet-flying clocks confirm this. GPS satellites adjust for time dilation daily. Let's twist it. Suppose you both take ships, speeding in opposite directions. Who ages less? It depends on who accelerates to reunite. You laugh, imagining a galactic sibling rivalry. I'm younger. No, I am. This isn't just physics, it's personal. Ever feel time slip away during a busy week, like vacations vanishing in Section 1? The twin paradox scales that to light years. Some physicists like Max Born argued it's no paradox, just relativity doing its job. Others say it exposes how unintuitive time is, like Zeno's motion mirage from Section 2. This hits home as you stare at your ceiling, shadows shifting. You've aged through choices, late nights, early mornings, while friends seem frozen in time. The paradox asks, is time a universal clock or a personal one? You recall Fermi's aliens from Section 6. Maybe they're zipping so fast their time's a whisper. You smirk, picturing a cosmic DM, yo Earth, you're aging slow. As the spaceship fades, stars blurring, you drift, fans hum softening, wondering if time's just a race where you're always trailing your own twin. You're still drifting from the twin paradox, that spaceship jaunt where you out-youthed your twin while stars blurred past. The fans hum, your cozy constant since the lights dimmed, pulls you from the cockpit into a paradox that swaps cosmic clocks for a voting booth's chaos. Welcome to Arrow's Voting Impossibility, where you're not dodging time dilation but wrestling with a system that makes choosing a winner feel like herding cats. Picture yourself in a bustling town hall, not a spaceship, ballots scattered like sand from Section 9's vague heap, as voters shout their picks. A mainstream fact: Kenneth Arrow's 1951 impossibility theorem proved no voting system can perfectly satisfy fairness criteria. Historians still argue whether Arrow's work killed hope for ideal democracy or just set realistic boundaries. For a quirky tidbit, Arrow's theorem inspired a 2008 X post back when it was Twitter, joking that elections are mathematically doomed. It got 12 likes. Here's the setup. You're in a small town picking a mayor from 3 candidates: Alice, Bob, and Carol. Voters rank them, say you prefer Alice over Bob over Carol. Arrow says a fair system should respect everyone's rankings, avoid dictators, no single voter picks the winner, and be consistent. If Alice beats Bob and Bob beats Carol, Alice beats Carol. Sounds reasonable. But Arrow's theorem proves no system can tick all boxes without breaking. You tally votes and Alice wins. Then a few voters tweak their rankings and suddenly Carol's mayor. Your brain's spinning like a bad campaign ad. You chuckle, imagining an X post: voted for Alice, got Carol. Thanks math. #election paradox. This paradox is a gut punch to fairness. Voting should be simple, like picking a pizza topping. Pepperoni wins, done. But Arrow shows it's messier than the liar paradox's napkin from Section 10. One fix is tweaking the system. First past the post ignores rankings, but it can crown a loser loved by few. Ranked choice voting helps, but it still trips over Arrow's rules. You're lying there, fan humming at 8:33 p.m. Pacific Daylight Time, picturing a cosmic election where aliens from Section 6 vote for best planet. Earth loses because, well, math. Let's twist it. Suppose you're not electing a mayor but ranking X posts for most viral. You like post A over B over C. But the algorithm, trying to be fair, flips the winner based on a few likes. You laugh, picturing a galactic influencer raging, "My meme deserved better." This isn't just politics, it's everywhere. Ever try group plans where no restaurant satisfies everyone? Arrow's ghost smirks. Game theorists like Amartya Sen suggest relaxing Arrow's rules, but fairness stays elusive, like Barry's unnameable number from Section 11. This hits home as you stare at your ceiling, shadows swaying. You've argued over movie night picks, feeling like no choice wins. Arrow's paradox says your group's doomed to disagree unless someone plays dictator. Yep, that's you picking sci-fi again. You recall the notebook from Section 5, looping without origin, voting loops without fairness. As the town hall fades, ballots piling up, you drift, fans hum softening, wondering if democracy's just a paradox we pretend to solve. You're still shaking off the chaos of Arrow's voting impossibility, that town hall where ballots betrayed fairness like a bad plot twist. The fans hum, your trusty anchor since the lights dimmed, guides you from the shouting voters into a paradox that swaps election woes for a psychic game of trust. Welcome to Newcomb's Predictor Game, where you're not counting votes but facing a choice that makes your head spin like a cosmic coin toss. Picture yourself in a sterile room, not a noisy hall, with 2 boxes on a table. One transparent, holding $1,000, and one opaque, holding either $1 million or nothing. A mainstream fact: Robert Nozick introduced Newcomb's paradox in 1969 to probe free will and decision theory. Historians still argue whether the paradox favors determinism or defends human choice. For a quirky tidbit, in 1980s game theory circles, Newcomb's problem was so divisive that some academics bet beers on their answers. Spoiler: no one agreed who won. Here's the setup. A superintelligent predictor, let's say an AI with a creepy knack for reading you, claims it's already decided what's in the opaque box based on your choice. If it predicted you'd take only the opaque box, it put $1 million inside. If it predicted you'd take both boxes, it left the opaque one empty. You see the $1,000 in the transparent box, tempting you. Take both, and you're guaranteed at least $1,000, maybe $1,001,000 if the predictor misjudged. Take only the opaque box and you're betting on the million, but if it's empty you get nothing. You're sweating, fan humming at 8:34 p.m. Pacific Daylight Time, picturing the AI smirking like the liar paradox's napkin from Section 10. You chuckle, imagining an X post: took both boxes, got $1,000. Regret level, infinite. #Newcomb's trap. This paradox pits logic against intuition. Causal decision theory says take both, whatever's in the opaque box is set, so grab the extra $1,000. But evidential decision theory says take one, If you're the type to take one, the predictor likely gave you the million. It's like the twin paradox from section 12. Your choice bends outcomes, but how? You recall Schrodinger's cat from section 4, boxes hiding truths until opened. If the predictor's perfect, one boxing's the win, but free will screams, don't let an AI puppet you. You laugh, picturing a cosmic game show host saying, choose wisely or it's just pocket change. Let's twist it. Suppose the predictor's not perfect, just 99% accurate. Does that change your pick? Or what if it's you from the future, like the Bootstrap Paradox's notebook from section 5, predicting your move? Your brain's doing loops. Philosophers like David Lewis argue two boxing preserves free will, while others like Eliezer Yudkowsky lean one box for the payout. This isn't just theoretical. Think job offers or ex posts. Do you play safe or bet on being predictable? You smirk, imagining the predictor demanding you, I knew you'd overthink this. This hits home as you lie there, shadows pooling. Ever faced a choice where overthinking felt like losing? Newcomb's game mirrors that. Trust yourself or the system. You recall Fermi's aliens from section 6. Maybe they're silent because they one-box their way into hiding. As the sterile room fades, boxes unopened, you drift, fans hum softening, wondering if your choices are yours or just moves in a game you didn't start. You're still reeling from Newcomb's predictor game, those boxes taunting you with choices that twisted free will like a cosmic Rubik's Cube. The fans hum, your faithful companion since the lights dimmed, draws you from that sterile room into the final paradox, a fairy tale gamble that makes psychic AIs seem straightforward. Welcome to Sleeping Beauty's odds, where you're not picking boxes but waking up to a coin toss puzzle that splits your reality. Picture yourself in a softly lit chamber, not a game show set, lying on a velvet bed as part of a strange experiment. A mainstream fact: the Sleeping Beauty problem, proposed by philosopher Adam Elga in 2000, probes probability and belief in decision theory. Historians still argue whether it's a paradox of math or just a clash of perspectives. For a quirky tidbit, the problem's name comes from the fairy tale, but some ex-users in 2010's philosophy threads called it the creepiest thought experiment ever. No dragons, just stats. Here's the setup. Scientists flip a fair coin Sunday night. If it's heads, they wake you once on Monday, then send you home. If it's tails, they wake you Monday and Tuesday, but a drug erases your Monday memory before Tuesday's wake-up. Each time you wake, you're asked, what's the probability the coin was heads? You're groggy, fan humming at 8:35 p.m. Pacific Daylight Time, unsure if it's Monday or Tuesday. You reason, if it's heads you're waking once, if tails twice. So, are the odds 1 to 2 like a coin flip or 1/3 since tails means more wake-ups? You chuckle, imagining an ex-post, woke up, forgot yesterday. Am I cursed? Hashtag Sleeping Beauty Math. This paradox is a probability knife fight. Halfers say it's 1/2, you're reasoning about the coin, which is fair. Thirders say 1/3, each wake-up is equally likely and 2 of 3 involve tails. It's like Newcomb's boxes from section 14. Logic pulls both ways. You recall the vague heap from section 9. When does likely shift? Halfers lean on the coin's fairness, like Arrow's voting rules from section 13 seeking clarity. Thirders count wake-ups, like Hilbert's Infinite Hotel from section 8 fitting extra guests. You're lying there, picturing a cosmic bookie laughing, place your bets, beauty. Let's twist it. Suppose you're woken a million times for tails. Does that make heads feel impossible? Your gut screams 1/2, but math nudges 1/3. You laugh, imagining a fairy tale where Sleeping Beauty's a stats nerd, scribbling Bayes' theorem on her pillow. Philosophers like David Lewis back halfers, tying belief to the coin's toss. Others like Elga argue thirders capture your experience, waking up is data. This isn't just academic, think A/B tests on X ads. Do you trust raw odds or user clicks? You smirk, picturing Beauty tweeting, coin's fair but my brain's not. This hits home as you sink deeper, shadows softening. Ever woken up unsure what day it is, life feeling like a loop? Sleeping Beauty's odds mirror that haze. Trust your logic or your gut. You recall the notebook from section 5, looping without origin. Here, wake-ups loop without memory. As the chamber fades, velvet bed dissolving, you ponder if reality's just a coin toss you keep reliving. The fan's hum slows your thoughts, a gentle drone weaving through the night. You're no longer Sleeping Beauty, nor chasing paradoxes through time, space, or logic. The stars outside, glimpsed in section 6, fade into a velvet sky, their silence now a comfort, not a puzzle. Your room feels softer, shadows pooling like spilled ink, each paradox. Zeno's halves, Schrodinger's cat, Barry's number, melting into a dreamlike haze. You're safe here, wrapped in the quiet of 8:36 p.m. Pacific Daylight Time, where questions don't need answers. Let the coin flips and infinite hotels drift away, like leaves on a stream. The universe can keep its secrets tonight. Your breath slows, matching the fan's rhythm, and the world hushes to a whisper. Sleep's calling, gentle and sure. Let it carry you.